Welcome to this top-tier engineering project, turning a washing machine motor into a generator. We begin with an aerodynamic vertical axis wind turbine. The expert starts by placing an old motor on the table. This is an asynchronous AC motor. A quick electrical test proves that the stator winding is still in perfect condition. The dismantling process begins. He uses a T-handle wrench to remove the through bolt securing the casing. A ring spanner is used to hold the nuts on the opposite side. His hand movements are extremely decisive and precise. A few technical hammer taps break the bond of rust, allowing the two metal casing halves to be separated. The motor core is revealed, and the squirrel cage rotor is pulled out. The intact stator winding will serve as the induction generator core. The key lies in the rotor. A red marker is used to evenly divide the steel surface into 8 extremely precise sections. He carefully marks alternating north N poles and south S poles, establishing an optimal alternating magnetic field layout. The rotor is clamped tightly into a mechanical vise. A high-speed angle grinder is immediately used to mill grooves into the metal. Brilliant friction sparks fly as the technical steel is ground away, creating slots that perfectly fit the permanent magnets. Eight deep slots corresponding to the 8 magnetic poles are cut evenly to ensure dynamic balance when rotating. The machining process continues on a drill press. A drill bit bores deep into the bottom of the slots to reduce Foucault eddy currents, while also creating an ideally rough surface. To help the industrial adhesive bond the magnets more securely, a large metal cutting disc is used to flatten the ridges, preparing a perfect contact surface. And here is the core material: rare earth neodymium magnet blocks with extremely strong magnetic flux density. Fast-setting superglue is applied along the slot. The expert presses the first magnet firmly, fitting it perfectly into the rotor. The rule of alternating NS magnetic poles is strictly followed. To optimize magnetic flux cutting, each neodymium magnet block is meticulously glued into a slot. The alternating magnetic poles create an optimal rotating magnetic field. The industrial adhesive penetrates, locking the magnets tightly against high centrifugal force. The rotor has now been transformed into a permanent magnet. He reassembles the magnetic rotor into the stator core, containing the copper windings. The immense magnetic pull requires a steady hand. He closes the protective casing covers and lightly taps with a hammer to concentrically align the bearings, ensuring the rotating shaft is absolutely smooth and perfect. The through bolts are tightened with a wrench and socket. The air gap is finely adjusted to be as small as possible. This maximizes the electromagnetic induction efficiency, according to Faraday's law. The motor block has been completely transformed. Now for the practical test. The rotor shaft is chucked into a cordless drill. The two stator wires are connected directly to a light bulb. The drill spins. The The continuously changing magnetic flux pierces through the winding. The bulb lights up brightly, proving its electrical efficiency. He upgrades the load with a high-capacity 3-phase motor. The generated current is strong enough to spin this motor shaft too. Next, he moves on to building the aerodynamic support frame. Galvanized square steel tubing is carefully measured and detailedly marked. An angle grinder slices cleanly through the metal clamped in the vise. These struts are prepared to bear heavy loads and constant vibration. A mechanical coupling is hammered tightly onto the rotor shaft, reinforcing its grip in preparation for mechanical power transmission. A pinhole is drilled completely through both metal layers, locking the rotational movement to transmit power from the turbine blades. He begins arc welding the cross-shaped main axis frame structure, measuring and arranging it accurately according to its geometry. Welding sparks fly brightly. The melting weld connects everything into a solid unit, creating a sturdy launching pad for this green energy source. The arc welds are continuously filled in to join the struts. A hammer chips away the slag, revealing a robust cross-shaped steel structure. He dry fits the cross frame onto the generator shaft to test it, then moves on to welding the foundation base frame. Using large, heavy-duty square steel tubing, a tall, galvanized round steel mast is welded perpendicular to the base. This will be the wind-catching mast for the entire system. He cuts a section of thin steel pipe and slits it lengthwise. This is the sleeve that will clamp tightly onto the generator body. He slips the sleeve over the casing and tack welds it at multiple points to lock its position. After cleaning it up, the connecting mount is ready to be attached to the main mast. This motor block, the completed generator, is then lifted up. He mounts it straight onto the top of the tall steel mast. The secret to the turbine blades is using large diameter PVC pipes. Measuring and cutting the pipes lengthwise creates 4 aerodynamic wind-catching blades. He securely welds the cross-shaped frame to the rotor shaft, making it extremely sturdy. He screws the 4 PVC blades tightly onto the 4 steel branches. He moves the entire vertical axis. Wind turbine tower outdoors. The Savonius type wind turbine is ready to convert kinetic energy into electricity. To counter the tipping force and heavy torque, the base needs to be reinforced. 2 heavy reinforced concrete beams are pressed tightly against the frame. He connects the electrical wires extending from the stator coil down to the ground. As the wind picks up, the aerodynamic turbine immediately starts spinning powerfully. The alternating current, AC, is routed directly to a standard household socket. Clean energy is now ready to be tested with the equipment. The expert decides to bypass light loads, moving straight to the heavy load challenge. A high-capacity metal cutting saw is brought out, followed by a handheld wood planer that requires a high starting current. They are all plugged directly into the newly home-built wind power source. Amazingly, the brushed motors of the power tools roar to life powerfully. The project to build a vertical axis wind power station is a massive success.